Trilochon here from Silan Software Pvt. In this video, we will see a machine learning project that is diabetes prediction using logistic regression. Logistic regression is one of the classification algorithm under supervised machine learning. So as we know, classification meant for categorical value that may be binary classification or multi classification. So here diabetes prediction example is a binary classification. That means the outcome will be 0 or 1. So guys, first of all, we will go to the data set. In Google, if I will type diabetes data set, you see, so we will get the diabetes data set from Kaggle, and you see the detailed information about the data set that you can get here, and this what are the features of the data set. So everything is given. So pregnancy is glucose, blood pressure, skin thickness, insulin. So these are the features. That means these are the columns. BMI, body mass index, diabetes, pedigree functions, age, and outcome. So 0 or 1. So if you will go through this site, you can get the data set, and here you see there is a download option, so we can download this file, and you see this file name is diabetes.csv file. So diabetes.csv is a what is a Microsoft Excel file. It is an Excel file in comma separated value format. So just to see, this is download option, you can download here. If you will click here, then diabetes.csv file will download. So already I have downloaded. So and this file that I have kept in my desktop, and here also I have kept in my A drive, and in my A drive that I have a folder, datasets folder, and here I have kept. So coming to our point, so here I have used Jupyter Notebook environment. So guys, the first point, we will get the required data set. So currently we knew how we got our data set for our task. So diabetes data set we downloaded from Kaggle, and our file name is diabetes.csv file. So in my Jupyter notebook, first one thing that you do, you can upload that data set here also directly. There is an upload option. So I will go to desktop. That file also I have kept in my desktop. So you see, so this is my file, whatever I have downloaded from Kaggle. Now I will click on open button, and I will click on upload. You see, so here diabetes.csv file. So here this file came to my environment. So this diabetes.csv file came to Jupyter Notebook environment. So now we will start. So completely we have implemented logistic regression. We will implement and using Python. So first of all, so some libraries so that we have to import. So guys, one point you remember, so before entering into machine learning, some libraries that you have to know, that is prerequisite. So import libraries. So pandas, numpy, matplotlib, cburn. So basic libraries, Python libraries that you have to know before entering into machine learning. So here I will import some libraries. Import pandas as pd, import numpy as np, import matplotlib dot pyplot as plt, import cburn as sns. So first four libraries I imported. In the middle, whatever the library that I will import, that we will see as per our requirement. So pandas, numpy, matplotlib, cburn we imported. pd is the alias of pandas, nv is the alias of numpy, plt is the alias of pyplot. Pyplot is a sub module of matplotlib in Python context, so it is also called as module. Matplotlib is a module, numpy is a module. Similarly, import cburn as sns. Sns is the alias of cburn. So now I will hit run. So whatever the alias we are specifying, so the purpose is what? Suppose PD is the alias of pandas. That means whatever the pandas library containing built-in functions, that built-in functions we will invoke by PD. This is the purpose of alias. Now, so happily we imported all the libraries, pandas, numpy, matplotlib and cburn. Now we will go to the next point. So first of all, we will create a data frame. Create a data frame. So as we know, a data frame is a data structure of pandas. So already we have a diabetes.csv file. So by taking the diabetes.csv file, we will create a data frame. Let my data frame name is, suppose let df. So pd dot read underscore csv function. So how to create a data frame? By taking a csv file. So there is a built-in function. The function name is read underscore csv. So this function coming from pandas library. That's why it is invoking by pandas alias pd. And within bracket, so I will specify the file name, that is diabetes.csv file. So now, so what is my df data frame? So here df. So now by taking diabetes.csv file, I am creating a data frame. So let my data frame name is df. So I want to see that data frame. Now I will hit run. You see, then immediately we got our data frame. So I want to see in shortcut manner. So if I will write Just I'm giving this line as comment. If I will give df dot head function, if I will call head function, so it will display first five number of records. If I will hit run, so you see, so this is my data frame. So this is my data frame, and you see it is clearly visible that this data frame, whatever I created by taking diabetes.csv file, so how many pictures or how many columns, so 1 2 3 4 5 6 7 8 9, so totally there are 9 number of columns: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and outcome. So you see the last column, outcome. So this column containing 1 or 0. So this column so is output column. Okay, so step number 2 completed. Simply we created a data frame by taking our diabetes.csv file. Now we will do some data pre-processing. That means we will do exploratory data analysis. So regarding data frame, we will know in detail. So how many, if I want to know how many number of rows and totally how many number of columns. So what I will write df, my data frame name is, and there is a keyword save. Now I will hit run. You see, so 768 comma 9, so what it is representing, so there are 768 number of rows and 9 number of columns. Okay, so save keyword. So if I will execute, if I will run, then I am getting this. I want to know the information. I want to know the detail about the data frame. So what I have to run df dot info function. So now I will hit run. You see, when I will call info function, and the detailed information about the data frame df immediately came to the picture. So you see the 760 entries, that means there are 768, that means 0 to 767. So 768 number of records, so 0 to 767 index, and the total number of column is 9. These are the column names, and all are non-null. That means all column containing non-null value, and data type are int 64 and float 64 types of data. So overall, this line, when I will run, so whatever the point coming to our picture, so it is quite representing, or it is describing the information about our data frame in detail. Then we will go to another function. If I want to know some statistical information regarding our data frame, so I will call describe function. I will call describe function. Now I will hit run. You see, so when describe function I called, so some statistical information that I got. So for this, suppose individually each column information so came to the picture. So in pregnancy column, these are the count number of data items. So this is the mean of this column, so standard deviation value of this column, this is the minimum so value. So coming to the percentile, so 25%. So 25% values are below or less than 1 point. This 50% values are below 3 in pregnancy column. Similarly, 75% value are below or less than 6 in pregnancy column, and the maximum value of this column is 17. So in this way, this is representing what? Some statistical informations like count, mean, standard deviation, max value, and some percentile value. So then we will go to the next point. So now we will check whether what missing value, some the data frame having missing value or not. So how I will check? Data frame name is df, so there is a function is now function dot sum function. So checking a missing value, check to check 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 missing values. Now I will hit run. You see, so there is no missing values in every column. Pregnancy is 0, glucose 0. You see in every column, so 0. That means there is no missing values. Okay, so some little bit analysis that we did regarding our data frame, checking missing values, getting some statistical information, getting information in detail, how many number of rows and how many number of columns are in my data set. So overall some analysis that we did. Now, then no doubt logistic regression is a supervised machine learning algorithm under the concept of classification. So guys, what do you mean by a supervised machine learning? By taking the value of x, so whatever we will create the model will predict the value of y. And here the y value is a categorical value, 0 or 1. So this is the overall concept of supervised machine learning. That means by taking the value of x, so here x means input feature or independent variables. By taking the value of x, the model will predict the value of y. Y is output feature or output variable, dependent variable. So from this data frame df, so we will consider what which column that we will consider as inputs and which column that we will consider as output. So clearly, so it is visible the output column, that is outcome, because the value is 0 or 1, and outcome column and remaining columns that we can consider as x. So that's why the next point is, so we have to we have to choose x and y. So x uppercase x, y is lowercase y. Guys, you remember uppercase x representing input features, input variables, whereas lowercase y meant for output variable or dependent variable. So now I will write x equals to, so what I will write, df dot, there is a method iLog. So it is a concept of pandas actually. So guys, so prerequisite is basic libraries that you have to know: pandas, numpy, matplotlib, and cburn. So it is a pandas concept. So in pandas context, there is a method iLog. Suppose if you will write colon, comma, then colon, and -1 dot values. So what it is representing, or what is the meaning of this line? So colon means, then colon, comma, after colon -1 all records. So colon means, then after comma colon -1 means apart -1 index. So in this way, 0th index, 1 index, 2 index, 3 index, 4 index, 5 index, 5 index, 6th index, 7th index, and 8th index. So in forward way, if we will see, in backward way, if you will see, it is a -1 index. So what we have written, the meaning is Appart minus one index column, appart minus one, this is outcome, this is the minus one index column, if we will see in a backward way. So appart minus one index column, all column, the remaining columns that we will consider as X, that means inputs, pregnancies, glucose values, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, function age. So this is the meaning of this line. So appart minus one index column, all remaining column values, all records, so considering as X. Similarly, I will choose Y. Same iloc method I will use, simply colon all records comma 8 index column values. So 8 means 8 index column, so 0 1 2 3 4 5 6 7 8. So 8 index column, that is outcome column values. Okay, so in this way we will choose which column values that we are considering as X and which column values that we will consider as Y. Now I will hit run. So happily we executed, that means we got X and Y. Then we will go to the next point. So as per the concepts, we will split our data set into, this is important point, into training and testing data set. In testing data, so whatever the data set we have, all data we will consider as training data, but from all training data we will consider some percentage, 20%, 25% or 15% of data that we will consider as testing data. So whatever we will create the logistic regression model, the model will predict, the model will work over testing data. So guys, so here the question is how we will split our given data set into training and testing data. So for that, so one built-in function that we have to call, but that built-in function that we have to import first. So from sklearn, there is another library from sklearn dot model underscore selection. So from this sklearn module, so there is a submodule model underscore selection. From this module, what we are importing, import train underscore test underscore split. So for this we have to import a module train underscore test underscore split. So this module is coming from sklearn dot model underscore selection, sklearn library it is coming. Then so in train underscore test underscore split module, there is a built-in function named as same, train underscore test underscore split function. There is a built-in function that we have to call. And within parenthesis, what we will, pass the parameter, what we will take the parameter. So input X, our output Y, then comma, so we have to specify, we have to pass, so testing size. So for that there is a keyword test underscore size, so equal, suppose I will take 25%, for that I will write 0.25. So train underscore test underscore split is a built-in function. So when it is invoking, so it is returning something. But first of all, we will know what the parameters, what the arguments that we will pass. So within parenthesis, so I passed input features that is uppercase X, and I passed output feature that is lowercase y. Test size 25% that I took, and another parameter, this is optional, random state, random underscore state equals to whatever an int value always that you specify. If you will go through Google and you type trend test bed function, that you can get the detail regarding this function. So many parameters that we can take, but the what proper the required parameter is input, output, and testing size percentage. So here we have considered from all our data, so we will consider 25% data our testing data. So guys, it is a such function when it will call. So it is returning for for numpy array. So that is what it is returning x on train, x train, x test, y train, y test. So this is a such built-in function when it is invoking. So it is returning for numpy array x train, x test, y train, y test. So if I will hit run, now I will hit run. So happily, so it executed. So if you want to see, so what is the value of x train, what is the value of x test, what is the value of y train and y test, y, so means dependent variable, x means input variable. Okay, so input variable again categorized as two things, x train, x test, and output similarly y train and y test. Suppose if I want to see, so what is the value of x test? So why I wanted to see the value of x test, because so whatever the model we will build, so the model will work on x test value. Okay, so now I will hit run. So you see, so these are the x test values. Okay, so already up at last column, the remaining column, that means there are 9 number of columns. One column that is outcome column, that is for output variable. Then remaining 8 column values that we have taken as input, and you see, so these are the values of x test. Similarly, if I will see what is the value of y test means this is the actual what output that is given, and I will hit run. You see, so this is the what y test values. So we will when we will go to the accuracy part, so we will check. So what the model is predicting, and what actual what output is given. So how much percentage of accuracy that we are getting. Okay, so now we will go to that to create the logistic regression model. So guys, you remember before creating the model, so whatever the steps that we did, so we can say that is called as what data pre-processing, or we can say EDA, exploratory data analysis. Now the time came, we will create a logistic regression model. Create, so logistic regression model. Okay, so there is a built-in class. Logistic regression is a built-in class which is available in sklearn library. So this class that I will import. So from sklearn, dot linear underscore model. So if sklearn, I will consider it is a module. Linear underscore model is a sub module. So that's why I wrote sklearn dot linear underscore model import logistic regression. Logistic regression. You see, now logistic regression is a built-in class that I imported. So now I will create a logistic regression object. So in Python, so how to create an object? Object name, let my object name is model equals to class name. Logistic regression. Object name equals to class name parenthesis. So in Python, so this is the way that we can create an object. Object name equals to class name parenthesis. So whatever the logistic regression object we created, that logistic regression object representing logistic regression model. So here my object name is model. So that model is the logistic regression model. Now I will hit run. So happily, so logistic regression model that we created, then we will train our model. So train the model. Okay, so once the model we created, basically in our context, model is called as a machine. So after creation of model, then we will train our model. So how to train the model? So there is a built-in function, fit function. That fit function coming from logistic regression class. So that's why fit function is invoking by logistic regression object. Here object name is model. So when fit function we are invoking, then logistic regression model that whatever we created, it will be trained. So fit, as per the concept, fit function taking two parameters, you guys remember, that is x train comma y train. Okay, so by taking x train values and y train values, so our model will be trained. Now I will hit run. So now, so happily, what model trained, if you see, this is the output. So train, our model is trained. So guys, in this way, we created a logistic regression model. Then after that, so we trained our model. So now after that, so model will predict. So how to predict? So there is a predict function. So like fit function, predict function is another built-in function. This built-in function also coming from logistic regression class. So that's why it is invoking by logistic regression object, that is model. So uh, already I have told when the model will work, model will predict over the testing data, X tests. Okay, so let it whatever the prediction model will do. Suppose let it the output variable. Suppose I will take let y prediction, and so what I will print, what is the value of y prediction? Y prediction. Now I will hit run. So now we got the output. Okay, so this output, strictly speaking, this is the prediction. So who provided? The model provided. Whatever we created logistic regression model, that logistic regression model provided this output or this predicted output. So we got y prediction. Already we have y test. So guys, already we have y test data. So y test and y prediction. So we will compare. So we will get accuracy. So we will see how much percentage of accuracy that we are getting. So there are what different ways that we can get the accuracy. So getting accuracy. So for that, to get accuracy, so from sklearn. So guys, you remember sklearn is one of the important library. So in every step that we are using this library. So from sklearn import, so one module we have to import from, that is matrix. Import matrix. Okay, import matrix. So there is a concept confusion matrix. So already in our channel that I have uploaded that videos what is confusion matrix and how the concept of confusion matrix that we will use for getting accuracy. So uh, you go through that video and you see in what Python context how I am doing. Suppose let it my matrix name is suppose let confusion cnf underscore matrix. Suppose let this is my output variable and so module name is matrix. Module name is matrix dot. So there is a function. Function name is confusion underscore matrix. So this is a built-in function, and within that, so always you remember when we will get the we will find the accuracy. So by taking y test and y prediction. Y test is actual output data and y prediction. So currently whatever the model predicted, so that model predicted value that I have assigned in y prediction. So y test and y prediction. So now I will print my output variable that is cnf underscore matrix. So now I will hit run. You see I got what so two subscript means two dimensional array that we have got. So 5 15 then 25 then 37. So one matrix that we got. So guys, how we will know what is the percentage? So there is a formula actually, diagonal element 115 plus 37. Okay, so 115 plus 37 divided by 115 plus 15 plus 25 plus 37. Okay, so 115 plus 37. So that is 152. So divided by 115 plus 15 plus 25 plus 37. That is 192. 152 divided by 192. Okay, so 79% I what calculated. So the output is 0.79, 79%. So accuracy is coming. And there is also another way that we can get directly also whether 79% is coming or not. You see 79% that we got. So through confusion matrix, we got 79. 115 plus 37 divided by all that item. 115 plus 15 plus 25 plus 37, that is 79. And by invoking accuracy underscore score function, I got also 79%. So the accuracy is 79%. Now, guys, this is what overall concept that we got. So we considered a diabetes data set. File name is diabetes.csv file, and we implemented one classification algorithm, supervised machine learning classification algorithm, that is logistic regression. And overall we created the logistic regression model, then we trained the model, then the model predicted, and also we got the accuracy. So we can create a system, that means we will give the input and whether we are getting output or not. So I can write making a predictive system. So now I will take some input. Okay, suppose one input I will take. Suppose if I will analyze, and so this is my file, and I will open with notepad. These are input. So these are input, and the last column is output. Out outcome column value. So last value is 1. So this is my input and this is 0 my output. So 0 means no diabetes, 1 means diabetes, or 0 means the person is not diabetic, 1 means the person is diabetic. Suppose one input, suppose I considered. Okay, so now I copied this and coming to my environment. Suppose I will take a variable. Suppose I will consider this input 1 2 3 4 5 6 7 8. So one input that I considered. So I will create a predictive system, and we will see how we are getting the output, whether this input I will feed. So what I am getting the output. So I am getting 0 or I am getting 1. So this is my point. Then so this data input, this is my input data now. So I will change my input data into numpy array, So because we saw every data item is in the form of numpy array, as a result, for when it will process by the control or model will process, so it will be so what perfect. So change our input data into numpy array. Let my variable name is, suppose I will take input underscore numpy underscore array equals to. So how it will change? So numpy alias is np dot. So there is a built-in function as array. So there is a built-in function as array. So it is coming from numpy library. That's why it is invoking by numpy alias np within bracket. So I will specify my input data. So I have taken what I have assigned in variable. That variable name is input. So what I did, so I what changed my input data into numpy array. Then what I will do, I will do the what size of the numpy array, means I will do the reshape operation. Why? Because one data point I picked, but there are 768 number of rows the data set is containing. So model have known, when the model have trained, so model have acquainted with 768 number of rows. But when one data point I picked, and if this data point in that format I will process, so that may be chances the model may predict a wrong result. So we have to change the size of that numpy array. So basically that is called as a reshape operation. So I can what reshape the array. So as we are predicting for one instance for, so as so okay, so it is deleted. uh, okay, so again I am writing, so making a predictive system. So somewhere, so it is deleted by mistakenly. So again I am writing, guys, making a predictive system. So guys, so let it my input, one variable, suppose I will take input data. So I will go to my file. So this part I will copy, and so I will paste here. Okay. So now I will change my input data into numpy array. So input, what I had written, input underscore numpy, let it, this is user defined, underscore array equals to np dot, there is a built-in function as array function. Within bracket I will specify input. So I changed my input data into numpy array, then I will perform a reshape operation. Perform a reshape operation. Perform reshape operation. Perform reshape operation because this input for predicting for one instance actually. So reshape operation, let my output variable let input underscore reshape equals to. So how to perform the reshape operation? Input underscore numpy underscore array that I have taken. So when my input data I have converted into numpy array, and that numpy array name is input underscore numpy underscore array. So this numpy array, so I will change the size. So I will perform a reshape operation. So for performing reshape operation, there is a function reshape. There is a function reshape, and syntax is within bracket what we will write 1 comma minus 1. So when this line what we will execute, so it will reshape. It will reshape. Then we will see directly what we will predict. We will predict. So let it. So after reshape, so directly we will go to prediction. Let it my variable output variable, and my object name is model.predict, and so within what in data I will what specify. So guys, if it will be possible, so we can standardize the data also. So if you want to scaling the data, sometimes the input data, the model what will not work properly. The model may provide what not accurate result. So at that time we have to what do the data, we have to scale the data, we have to standardize the data. So for that there is a built-in function, standard scalar function, that we have to call actually. So we'll see if the prediction is okay, then we will in the there is no need of what standardizing the data. If the prediction is okay, so there is no problem. So without scaling that we are doing, so within bracket, so what I will write input underscore reshape. Okay, so whatever after performing the reshape operation, so then suppose before that, suppose you will write print, suppose input underscore reshape. Then after that, suppose you I will write print prediction, print prediction. You will check. So now I will hit run. So you see, and whatever the inputs or data I had taken, whatever the input data I had taken, so I got print that data. So two output statements I have written here. This is the one output statement, and this is one output statement. So what is value of prediction? 0. Okay, so we will see. So really we will see. So this is the what my input data, what is the output? 0. So it is working fine. Okay, so it is working fine. So if I will write the business logic here, so just to point, if I will add some logic, very simple. If else, I will what add. If so, my output variable is prediction. Okay, prediction of 0 equals to 0. If 0 means what? No diabetes. Print. Okay, 0 means no diabetes. No diabetes. No diabetes. Else print diabetes. Okay, person having no diabetes, person having diabetes. Now I will hit run. You see, so I got happily, so the output is 0 and person having no diabetes. So whatever the output we got based on this output, so I can write a logic. So prediction of this. So if condition is true, if body will execute, otherwise else body will execute. So in this way that I created, so I made a prediction system. So any input that I can give, so I can get the output. Okay. So this is for 0 and so I will take another input for 1. Suppose next input, suppose I will take, suppose I copied, so here the output is 1, so I copied and so my input I changed. Now I will hit run. You see, so I got 1 and a person having diabetes. Okay, so whatever we made prediction system, I hope it is working fine. So guys, this is all about the project in detail. So diabetes prediction using logistic regression. So I hope every point you got the clarity one by one that I explained here. I hope everybody is understanding well. So this is all about diabetes prediction using logistic regression.